thank you to the organizers for giving me this opportunity to talk about my work. Today, I will be talking about the differential impacts and recovery needs of disaster affected communities in the Himalayan region. And this work that we and the group that I work with now, we've started, it's something that we've initiated about 10 year and a half. So a lot of the work that I'm presenting is something that we are still building on and collecting more data. So yeah, these are preliminary results, and I would like to get your feedback and address questions that are there. So particularly in the Himalayan region, the disaster risks exist. It's not a controversial statement. We all know that risks, disaster risk hazards are frequent in the region, and what's little more important and we need to pay attention to that these hazards have become more frequent in the recent time. So what we see, this data is coming from the EMDAT database that exists and has been analyzed by the Indian Environmental Report of 2024, and it's a decadal representation of how events have increased. And we see that in overall in India, the events are increasing, but 44% of the contribution of the natural hazards are occurring and happening in the Himalayan region. And when I say the Himalayan region, it constitutes the Western Himalayan states of Jammu Kashmir, Himachal Pradesh, Uttarakhand, and then the 9 sister states, Himalayan sister states that are there in the Northeast region. Then the second point that I like to also highlight and understand from for the work that we do is that the characteristics of these hazard processes are also changing. So, what we learned yesterday and what Ugur was also talking about, that a landslide is happening, it's happening, there are several triggering factors. There's intense rainfall that is causing it, but then the landslide process is causing further chain and cascade of events, and that is something that was maybe not so common or not so addressed previously, but is being identified as an increasing challenge in the Himalayan landscape. So what you see here in on the right is a hazard chain where, if we talk about a single hazard, then it's just the debris flow, but whereas debris flow leading to a landslide dam and causing a riverine flooding of an intense magnitude is something that extend it or extend the cascade chain. Then, as Ugur mentioned, that risk is a function of not just the hazard that exists, but the vulnerability, the exposed element, and the capacities of the communities, a system in place to adapt to these challenges. We also understand from our work that there's high vulnerability. When we understand vulnerability here, it's a composite of exposure, adaptive capacity, and sensitivity. So there is high vulnerability in the Himalayan region. As we can see here in these areas, all of this, there's a high vulnerability to disaster risks. And so that's a national perspective from one of the study that's coming. But when we analyzed it for the state of Uttarakhand, where we are now, we see that this study that we did was at a village level. We computed the vulnerability index for about 16,000 villages that are there in India, that are there in Uttarakhand, and we saw that there is a differential pattern, though the map of at the national scale, they all look in a similar color, most of the districts. But when we zoom down a little bit, we see that even within these highly vulnerable districts that are identified at a national scale, there's a lot of heterogeneity when we move down from national to a local scale, let's say village level. And then further on with some of the studies that I took up, we understood that even the areas where where we see this red color, in some of these areas where these are identified as hotspots of vulnerability, there's still a lot of differentiation in the kind of vulnerability impacts that are felt or exist at household level. So that work is also published, but I'm not presenting that here. But yeah, so from this slide, what I want to conclude is that the hazards, as we know, are increasing. This is compounded with the high layer or high magnitude of vulnerability that exists in the Himalayan region. What we know is something that these risks exist, but something that is also urgent for us to analyze and estimate is how much is the risk going to be in the future. So this is results of from one of the study that we are taking up, and we're looking at how many times does the threshold of 1.5 degree is being crossed for these grid points in India. And what we see, and this is at a monthly scale that we're doing this analysis, and we're just counting the number of times 1.5 degree is exceeded. And what we find here is that in the Himalayan region, where we are in most of these regions, the intensity of these extreme events, or the frequency of these extreme events, is greater than the other parts of India. And this is across all the RCP scenarios that are there. So this is a common pattern that we find here. So not that just risk exists, but the risks are going to be further intensified and more frequent in the coming time based on the data that we have, and we can assess that. Establishing that risks are existing, risks are going to further increase in the near future, in the time that that we have for action. The risks and the impacts are uneven. They are not constant across sectors, across regions, and across communities. So there has to be an inquiry of how these risks are differential across different sectors, maybe in urban and rural area, in agriculture based economies, in tourism based economies, in regions. So what does it look like when we are talking about Himachal Pradesh, when we're talking about Uttarakhand, or when we're talking about a remote area in Northeast? So these, there has to be an inquiry at a local level, is what I always try to do, and also advocate strongly. And then these are also differential across communities within the same region. When we face a certain kind of hazard, how each household reacts to these hazard processes is very different, and there has to be an inquiry of that process as well. So we, now what I'll be presenting is the work that we did with the team, and Anirban Mandal, who might be here, he did a lot of analysis, and this is something that we did together, is the case study of North Indian floods in of 2023. So in the Himachal Pradesh state, last year there was this extreme devastating event that happened. It caused a significant amount of losses. So we can see that the area of Himachal Pradesh consists about 18% of the Indian geographic area. Sorry, 18%. And then there have been, so this is data that is documented and coming from the scientific government assessment that we have quoted here. But there is also a bit of, question on whether these estimates are accurate, or rather underestimating the kind of damages that have happened during the event. So 61 landslides, 41 flash flood events, and it cost about 50 billion INR, Indian rupees, damage have been estimated. There have been huge loss to households, houses, and shops. Then about 400 people have died, and there's many more who are missing and injured. So this was one of the, in the recent time, this has been an event that has been one of the most devastating events that have happened in the Himalayan states. So what we did was that we tried to understand the flooding inundation or impact using remote sensing methods. That part I'm not presenting here. And then we tried to do the damage calculations based on these remote sensing, trying to get the inundation map, overlaying with the open street map and the land use land cover map, understanding how much the agriculture damage has happened, how much built up damage has happened. So that was one component of the approach that we had. And then the second component was to integrate it with the community surveys to understand what are the needs and impacts that communities and the households are reporting. So we interviewed around 344 households in the region. We interviewed more, but because of the data inconsistencies, we had to delete a few. And then this was what our questionnaire covered. We asked communities about their consent, which is the foremost most important thing. Then about the respondent, the household characteristics, then gathered information from them on the disaster which is that disaster that has affected them, how much is the intensity, and then impact on different sectors, then some of the institutional and social protection measures that have been given to them and provided to them, then about livelihood capital information and disaster mitigation and preparedness information at the household level. These are the 14 villages which were highly impacted. We went and we interviewed households that we see in green here in these locations, and these were in the Kullu and Mandi district of the Himachal Pradesh. And then finally, what this is one part of the assessment that we have, is we looked at the impact on 17 livelihood capitals are combined to generate the well-being and economic activities that the household is engaged in performing. What we see is that the households are reporting an intensive impact on the physical capitals. For instance, the road near which the nearby road is damaged, and the tourist places, access to that tourist place is also then lost. Highways are lost. Marketplace access is something which is extremely important for these communities, that is also not existing. That's the most impacted capital, following which the financial capital is secondly, which we identify as being affected. And then what is also not a lot of time incorporated is how these hazard processes or disasters affect the social well-being or social capital of the community, and that we also find that in the locations is reported to be heavily impacted. Yeah, this is a rather dense plot, that heat map that we see. So what it represents, the different color towards the red, it means that variables that we had on the previous slide are highly correlated with one another, whereas when we are in the blue, it means that they are negatively correlated. So I'm going to talk about some of the positive correlations. What we see here is that, marketplace access, health center access, education access, and work access, damage on these assets is highly correlated with one another. Then if there is agriculture loss, then in the same land horticulture is also being practiced, so there's high reporting on that. And then that leads to food shortages in the region. So what I want to convey with this slide is that these impacts are interconnected and are dependent on one another. The prime factor of this interconnection can be the road, which is the main accessibility point, very crucial for these geographic locations where we survey, because these are small valleys with only one or two paved roads that are going, and they're extremely important for the accessibility of these communities to be connected to the world outside. So, and that is what our study also brings forward, that physical assets in the Himalayan region are at the priority for the communities themselves to access all of these other allied services, be it healthcare, be it education, be it even the agriculture product that needs to be marketed. That so all of that then gets impacted in a cascading manner. Yeah. So we try to bring it all together in this kind of a causal loop diagram, where we identify the key direct events, which in the region was cloudburst, floods, and landslide. And then there is a cyclicity of how these are also connected. And then the major impact in an agriculture economy. So the sites we had, one was dominated by tourism, the other was dominated by agriculture. So the impacts and these causal loop also differ a little bit in the importance of these variables, depending on whether it was an agriculture dominated economy or it was a tourism dominated economy. And we see that we try to mentally put the connections in this causal loop diagram for us to understand, and similarly for the tourism based economy. But what I want to open it up for others, I know there are great modelers here and experts who are modeling. I also collaborate a lot with Ugur to learn some of his modeling skills. But yeah, that how do we capture, or do we capture these processes and interconnections in some of the loss and damages model that exist? Is it what is it that we really need to take into account, is something that is a question that I often ask myself. Then finally, coming to the recovery need, this is a generalized representation, averaging everything that the communities have said. Some of the colors maybe are not so visible. But yeah, immediately after the disaster event, this is the standard recovery cycle, where, immediately after the event, there are relief efforts that are there, and the community would need relief equipment, first aid, evacuation plans. And then after, in the short term, which is about 30 to a month to 2 months, there are other needs that become important: shelter, healthcare, food and water, access to safe drinking water and food, and also some kind of relief funds. But then, as time passes, and after the event, about 6 months, there are other needs that surface more importantly, that is in terms of getting access to a livelihood, in terms of what work they can be involved in. Maybe the disaster has taken away the land and they do not have any other skills. So then what is it that they can do for their livelihood? And this is something that, with our work forward, we further want to investigate and look into different factors that would create a spectrum in these recovery needs later, not long term recovery needs across the different societal factors. And this is the model that we have when we want to expand this spectrum, that we know this from our previous work, that recovery need is differentiated. It depends on many factors, and they can be clubbed broadly in among four factors. First is the hazard experience. So how much is the, or what kind of experience has the household has with the hazard? Is it that they're directly impacted or partially impacted? What is the intensity of that impact? Then the circumstances that exist for within the household for recovery, then some their psychological status and socioeconomic status, which is extremely important: gender, age, education, employment, ownership, and other factors. Yeah. And I would finally like to conclude by bringing out this quote from one of the respondents who we interviewed, that that we try to come up with solutions or come up with impact assessment for the immediate loss that has happened by a hazard process. For instance, flood, we just compute how much inundation has happened, what is the damage to a certain kind of building, and what's the debris then that is left behind after the water is gone. But what, as an individual who is affected by these hazards, says or puts in word, is that they feel that they've lost their efforts of 20 years. So it's not just by one event. They think that they've gone back 20 years in time, and their efforts, which in the mountain communities extremely, it's extremely, they put in a lot of manual effort for a lot of these exercising a lot of these daily sustenance, as compared to people who are living in cities in Delhi and Kolkata. So when we are talking about spatial inequalities in the hazard process within India, there is an immense spatial heterogeneity and in the capacities that households have and individuals have. So yeah, I think what's the way forward, apart from because models work, model when we also go and present our work, a lot of time, like we're doing something for the finance commission, they will ask us where are the numbers for it. But with a lot of these soft skill and with a lot of these voices that are coming from the community, we don't really also know how to incorporate them and get a number, an estimate of these losses and damages. These are more personal. So maybe a multi-sectoral approach to disaster management that I think already exists, but addressing the link and interconnections among impact is something which is crucial for a better planning of disaster events. Yeah. Thank you.